All right, for our next video, we're going to do 7, 8, and 9 together because they all have to do with naming. All right, and so this will make more sense when we go through lecture, but we have a little preparation screen here telling us how to name ionic compounds, which is a metal and a non-metal. And so basically you just list the metal as it's listed on the periodic table. Then you have a non-metal stem, and so it gives you some examples here, and then you add the ending "ide." So let's walk through that. So BAF, all right, so you might have to consult a periodic table when you do this, but Ba is barium, and then F is fluorine. But fluorine doesn't retain the same names. It goes to fluor. This is just the like stem, and then that changes from ene to ide. So this would be barium fluoride. Here we have Mg, which is magnesium. So the first one is going to retain its full name, so magnesium. And we have I here, that's iodine. And when it's in a compound, it changes to iodide. Instead of INE, it goes to IDE. Here we have Ca is calcium. And then S is sulfur. So instead of sulfur, it becomes sulfide, IDE. All right. And again, I did that because I know the chemicals and their formulas, but you might need to be consulting a periodic table. Okay. Kind of depends on where your periodic table knowledge is at. All right. Let's go ahead and type these in. So this looks similar. I'm not going to go through this one since we have three problems in this one, or three questions in this. All right. So now we're given two chemical symbols and we need to create the formula. So again, we're going to talk about this way more in lecture. This is just to really kind of make you not stress about not having all your owls in and stuff. So what happens is that when they go to form a compound, they swap charges. They're trying to create a net neutral charge. So Ni would take on the 2 minus charge, and sulfur would take on this 2 plus charge. Well, in this case, the 2 plus and the 2 minus cancel. And so their formula would just be NiS. Okay. Let's erase this so we can see the next one. So the next one is where we actually get a subscript. So this 2 is going to transfer, and this -1 is going to transfer. So copper, Cu, is going to take on a -1. -1s, we're not going to give a ones, we're not going to do subscripts for. It's implied. Br, bromine, is going to take on this 2. All right, 2 and 1 don't cancel out in this case. So this 2 is now going to become Br's subscript. All right. And again, we're going to have to see, I'll show you how to type that in here. All right. Here we have a +1 and a -1. +1 and -1 cancel each other out. So this one is going to be similar to the first one where we just list the elements as they're listed. This one already comes with a little compound on it with a subscript of 4. All right, so let's type this in now. So this one's easy. Let's see if I can remove that so we can see what we typed. Oops, good thing we did that. All right, so this one, NIS. Here, we need to add a subscript. So if when I click on here, we see this menu pop up. All right, so up here, this would be for superscripts, and this would be down here for subscripts. So at first, I'm going to type CUBR, and then I'm going to hit the subscript, and then it puts a little box lower, so I know that I can type in a 2 now. Right, NH subscript 4. I'm going to unclick it. There we go. Now I'm back to the normal I. There we go. All right, so same thing for this screen. You're just swapping the charges, and if they don't cancel, the swap charge becomes the subscript. So here we have PB, which has a +2, and iodine, which has a -1. So when they swap, iodine would have a 1 for a subscript, but we don't explicitly write out ones. Iodine would have a 2 for a subscript. Here, oh, this one's fun. We have cobalt swapping with oxygen. Cobalt has 3. It's going to swap with oxygen that has 2. So now cobalt is going to have a subscript of 2. Oxygen is going to have subscript of 3. Zinc and bromine. Zinc's going to swap with the bromide. The bromine has 1. We're not going to explicitly write out ones. Bromine is going to take on that 2, though, from zinc. All right. And the last one. So those were both ionic compounds. Here's covalent compounds. And covalent compounds are two nonmetals together. All right. So with the two nonmetals, the naming system works differently. All right. So you still list the first element as it is, and you still change the ending to "ide." But this time you tell the audience how many um, atoms there are, how many you tell the audience what the subscript is with a prefix. There is one exception to the rule, which is mono. If the first element is singular, you don't use mono. But if the second element is singular, you do use mono. So I love using carbon dioxide example. Obviously, this textbook thinks the same. So CO is carbon monoxide. CO2 is carbon dioxide. So that 2 is what made us change the prefix. Okay. Again, we'll talk more in lecture. All right, so let's see here. Let's start with this one since uh, our preparation showed us going from symbol to name. So tetra is going to be 4. So right here, tetra. So I have 4 here. So tetra phosphorus. Again, you might need to consult a periodic table, but I know that P is phosphorus. And we have 10 oxygen. So let's consult this. Deca oxide. And you drop one of the vowels when you have 2 vowels, and I believe you leave the second vowel. Okay. So this would be monophosphorus, except the one exception to the rule is you don't list mono on the first element. So it becomes phosphorus, and then 3 is tri here. So tri fluor. No, why am I capitalizing fluoride? Why is oh there phosphorus? Okay, carbon. All right, and we don't say mono because it's the first element, but there is 4 on the second element. We saw earlier that 4 is tetra, so tetra fluoride. Ooh, spelling. All right, so here we're gonna check my deca oxide. If it gives me an error, I think, oh no, it accepted it. Okay, it spelled it differently, but it still accepted it. All right, so now we're gonna go backwards here. So xenon, all right, doesn't have a mono, di, tri, tetra, or anything listed in it, so it must be singular, and xenon is Xe. Tri, meaning 3, oxygen representing um o oxide, sorry, representing oxygen. So that tri is telling me that it has a 3 on it. So I do capital E, Xe, and then capital O, subscript 3. All right, here this di is telling me 2. So nitrogen has a 2, and then tetra telling me 4. So fluorine has a 4. So N2, unclick, fluorine, 4. Nitrogen doesn't have anything on it, so it must be by itself. And then we have tri telling me that there's 3 fluorines. NF3. There we go.